Effusion and diffusion. Effusion is the passing of a gas through a tiny hole into an empty chamber. So if we look at this picture as an example, we start over here on the left-hand side with gas particles that are moving around. On the right-hand side of this container, we have a vacuum, meaning there are no gas particles. And the rate at which the gas particles move from this side through the pinhole into this side is called the rate of effusion. Diffusion is very similar. It's the mixture of gases. So if we were to look at this as an example, we have a hollow glass tube, kind of like a straw. On this side, we have a cotton ball that's wet with ammonia. And on this side, we have a cotton ball that's wet with hydrochloric acid. Each of those liquids will release gases. The ammonia gas will diffuse in this direction. The hydrochloric acid gas will diffuse in this direction. And when the hydrochloric acid and the ammonia meet, they produce ammonium chloride, which is a white solid. And what we should notice is that this white solid doesn't form in the middle of our two samples, but much closer to the hydrochloric acid side than to the ammonia side. And the reason for that has to do with the masses of the particles. The heavier the particles, the slower they move. The lighter the particles, the faster they move. So what we're talking about is what's called Graham's law. Let's say that we have two gases that are at the same temperature. If they're at the same temperature, they have the same average kinetic energy. Now we should remember that kinetic energy equals 1/2 mv squared, where m is mass and v is velocity. So if we have two gases that are at the same temperature, they have the same average kinetic energy. So what we can do is we can say 1/2 m1 v1 squared equals 1/2 m2 v2 squared. So this is the information about gas 1. This is the information about gas 2. Now the first thing that will happen is the 1/2s will cancel out. And then we want to isolate the velocities on one side of the equation and the molar masses on the other side of the equation. So what we're going to do is divide both sides by v2 squared and divide both sides by m1. That's going to give us v1 squared over v2 squared equals m2 over m1. Now we don't want the velocities squared, we just want the ratio of their velocities, so we're going to take the square root of both sides. And what that's going to leave us with is the Graham's law equation. The relative rate of diffusion of two gases equals the square root of their inverse molar masses. Notice V1 is here, but M1 is here. V2 is here, M2 is here. So it's a square root of the inverse molar masses. In other words, the heavier the particles, the slower they move. The lighter the particles, the faster they move. So here's an example. Find the relative rates of diffusion for the gases krypton and bromine. Now we're not actually finding their rates, we're just finding their relative rates. So we're going to look up krypton on the periodic table, and it's going to tell us that the molar mass is 83.80 grams per mole. We have to remember that bromine is diatomic, and that's going to give us 159.80 grams per mole. So when we look at these two gases, we know that krypton is going to diffuse faster than bromine because it's lighter. And the gas that diffuses faster is the gas we're going to designate as gas 1. So we've got V1 over V2 equals the square root of M2 over M1. We're going to make krypton 1 and bromine 2, so the velocity of krypton to the velocity of bromine will equal the square root of the molar mass of bromine, which is 159.80, over the molar mass of krypton, which is 83.8. So we'll take 159.8 divided by 83.8, take the square root of that, and what we're going to find is a 1.38 to 1 ratio of rates for krypton to bromine. That means that krypton diffuses 1.38 times faster than bromine does. All right, so let's look at another problem. This time it tells us that hydrogen gas diffuses 4.34 times faster than gas A. What is the molar mass of gas A, and what is gas A? So we have hydrogen gas, and we have gas A. Now hydrogen gas diffuses faster, that means that it's lighter. And the relative rate of diffusion is 4.34 to 1. And that's going to equal the square root of the inverse molar masses. We don't know the mass of gas A, but hydrogen, which is diatomic, is 2.02. So we would square both sides, then multiply both sides by 2.02, and we would get a molar mass for our unknown gas to be 38.05 grams per mole. Now we want to identify what the gas is, and when we look on the periodic table, there is no particular element that has a molar mass of 38.05 grams. But if we think about our diatomic molecules or our Honkobriff molecules, fluorine, which is diatomic, would be 38. So our unknown gas must be fluorine.